Executing multi-line statements in the one-line command line. I'm using Python with C to execute a one-liner loop, i.e. This works fine. However, if I import a module before the for loop, I get a syntax error. How can this be fixed? It's important to me to have this as a one-liner so that I can include it in a makefile.
You could do or without pipes, or silent ghosts answer or press answer.
This style can be used in makefiles too, and in fact it is used quite often. Or with hard tabs. In above case, leading tab characters are removed too, and some structured outlook can be achieved. Instead of EOF can stand any marker word not appearing in the here document at the beginning of a line. See also here documents in the bash man page or here.
The issue is not actually with the import statement. It's with anything being before the for loop. Or more specifically, anything appearing before an inline block. For example, these all work. If import being a statement were an issue, this would work, but it doesn't. For your very basic example, you could rewrite it as this. However, lambdas can only execute expressions, not statements or multiple statements, so you may still be unable to do the thing you want to do. However, between generator expressions, list comprehension, lambdas, sys.stout.write, the map built in, and some creative string interpolation, you can do some powerful one-liners. The question is, how far do you want to go, and at what point is it not better to write a small .py file which your makefile executes instead?
To make this answer work with Python 3.x as well, print is called as a function. In 3.x, only printfoo works, whereas 2.x also accepts printfoo. For a cross-platform perspective that includes Windows, see KXR's helpful answer. In Bash, KSH, or ZSH. Use an ANSI C quoted string, $, which allows using \n to represent new lines that are expanded to actual new lines before the string is passed to Python. Note the \n between the import and for statements to effect a line break. To pass shell variable values to such a command, it is safest to use arguments and access them via sys.argv inside the Python script. See below for a discussion of the pros and cons of using an escape sequence preprocessed, double-quoted command string with embedded shell variable references. To work safely with $... strings. Double instances in your original source code. \char sequences, such as \n in this case, but also the usual suspects such as \t, \r, \b, are expanded by $c, man printf, for the supported escapes. Escape instances as \. If you must remain POSIX compliant, use printf with a command substitution. To work safely with this type of string, Double, instances in your original source code. \char, sequences, such as \n in this case, but also the usual suspects such as \t, \r, \b, are expanded by printf, c, man printf, for the supported escape sequences. Pass a single quoted string to print %b and escape embedded single quotes as \sic. Using single quotes protects the string's contents from interpretation by the shell. That said, for short Python scripts, as in this case, you can use a double quoted string to incorporate shell variable values into your scripts, as long as you're aware of the associated pitfalls. See next point. For example, the shell expands $home to the current user's home dir. In the following command, Python C $print %b import sys / and for our in range 10 column print rob as $home. However, the generally preferred approach is to pass values from the shell via arguments, and access them via sys.argv in Python. The equivalent of the above command is Python C $print %b import sys / and for our in range 10 column print rob is plus sys.argv1, $home. While using a double quoted string is more convenient, it allows you to use embedded single quotes on escaped and embedded double quotes as, it also makes the string subject to interpretation by the shell, which may or may not be the intent. And characters in your source code that are not meant for the shell may cause a syntax error or alter the string unexpectedly. Additionally, the shell's own processing in double quoted strings can get in the way. For instance, to get Python to produce literal output row \b, you must pass row \b to it. With a ... shell string and doubled instances, we get Python C $print %b import sys / and print row \bs, #ok column row \bs. By contrast, this does not work as intended with a ... shell string. Python C $print %b import sys / and print row \bs, incorrect column rs. The shell interprets both \b and \b as literal \b, requiring a dizzying number of additional instances to achieve the desired effect. Python C $print %b import sys / and print row \bs. To pass the code via stin rather than C. Note, I'm focusing on single-line solutions here. Zerho's answer shows how to use a multi-line here document. Be sure to quote the delimiter. However, for example, EOF, unless you explicitly want the shell to expand the string up front, which comes with the caveats noted above. In bash, ksh, or zsh, combine an ANSI C quoted string, $, with a here string, ... tells Python explicitly to read from stin, which it does by default. Is optional in this case, but if you also want to pass arguments to the scripts, you do need it to disambiguate the argument from a script file name. If you must remain POSIX compliant, use printf as above, but with a pipeline so as to pass its output via stin with an argument.
If you want to share more, classic consider subscribing.